I am Ando. I teach architecture at Hosei University in Tokyo, Japan. I would like to present our study on images of Japanese historic streetscapes by using automatic form generation. We created 3D models that simplify the forms of historic streetscapes to find the characteristics of their form compositions. We presented this animation in 2020 at the former national conference in Japan. This model was created manually from map data. Although it was a simple model, it took time and effort. For this ICGG conference, we create models automatically using computer programs instead of manual work. The animation is the automatically generated streetscapes of Takehara as an example. We intend to create a simplified model to represent the characteristics of the forms. It is not a realistic representation. However, we consider that even with this simplified model, it is possible to express the image of historic streetscapes. There may be criticism that it is oversimplified, but I think the simplification has the advantage of clarifying the characteristics. For the automatically generated 3D models, a certain degree of deviation is essential. In this study, we will find the rules and the fluctuations of forms in the historical streetscapes. In Japan, the Agency for Cultural Affairs designates historic streetscapes as the important preservation district for groups of traditional buildings. As of today, 126 districts have been designated. During this corona pandemic from 2020, we visited 71 districts, mainly in eastern Japan. The animation saw the streetscapes of Unnojuku. To survey the morphological composition of buildings facing major streets, we took videos of their exteriors using a 360-degree camera. In 50 out of the 71 districts, streetscapes are formed by lined-up buildings. In other 21 districts, farmhouses and lodges are dispersed in mountain villages, or streetscapes were not formed by buildings but by fences or plantings. The preservation districts are applied by residents. Although subsidies cover a part of the cost, the preservation is managed by the resident. Generally, in preserved areas, rebuilding and renovations are restricted, and the restriction causes inconvenience to residents. We observed not a few vacant houses left unoccupied. However, we consider that a historical streetscape does not necessarily have to be fully preserved, but can contain a diversity that corresponds to the lives of residents. With this in mind, we surveyed the streetscapes during this corona pandemic, when the number of tourists dramatically decreased. The shape of major roof types are gable, hipped, half-hipped, and modern flat. The wall parallel to the roof ridge, which is not the gable end but the side wall, is called hira, which is common that face the historic streets. When the entrance is on hira, it is called hira-iri. One of the characteristics of the streetscape is a series of eaves on hira-iri walls. On the other hand, some gable ends face the street and give an accent. We analyzed the composition of significant parts of streetscapes in 20 districts. Based on a visual inspection of buildings facing the street, we classified their forms into 7 types. The major types are hira-iri, gable, and modern, and the minor are hipped and half-hipped. The most common type was historic hira-iri with eaves, which includes not only original historic houses but reconstructed or newly built with traditional materials. When hirairi does not have traditional materials, we classified it into hybrid hirairi. The gable type has a gable roof end in the front. Modern type are box-shaped modern houses or buildings that are not traditional, regardless of the roof shapes. Half-hipped type is applied when the small gable faces the street. As the hipped roof is a type often found in scattered farmhouses, there are few examples of hipped roofs forming streetscapes. Others are exceptional buildings such as temples. Hirairi ratio in the table shows the ratio of both historic hirairi and hybrid hirairi to all houses. Gable ratio and modern ratio show the ratio of gable and modern. Observing the composition of these house types, we classified the streetscapes into 5 types A to E. In type A, more than 80% are hirairi with continuous eaves along the street, and the modern ratio is less than 15%. These streets are fully and well preserved and maintained, and many houses have been converted into restaurant, souvenir shops, or guest houses. It is considered that the background of tourism is essential for the preservation of historic streetscapes. As an example, Takayama Sanmachi has a row of townhouses with deep eaves. Sannezaka in Kyoto was where the conference dinner was held at ICGG 2010 in Kyoto. Sekijuku has a long and grand streetscape. In Mino, a row of hirairi with udatsu, a firewall on both ends, is characteristic. Type B is composed of hipped roofs. Ouchijuku was a prosperous lodge street, and it forms a streetscape with a row of such hipped roofs. Type C is a mix of hirairi and gable. For example, Takehara and Tondabayashi have a low modern rate and show a unique landscape with a balanced arrangement of hirairi and gable. In Tondabayashi, 59% were hirairi and 34% were gable, while in Takehara, hirairi and gable were almost equally distributed, each accounting for 43%. Type D is streetscapes where hirairi and modern coexist. In Arimatsu, 55% were hirairi and 34% were modern. In Gojo Shinmachi, 78% were hirairi and 90% were modern. Sahara is distinguished by its canal-fronted streets. In Type E, most buildings are modern, and many parking lots exist. In Inariyama, about 40% of the site facing the street are vacant, such as parking lots. The modern rate is quite high at 51%, and historic houses are few. However, some valuable historic heritage remains. A museum is housed in a historic building, which tell the story of how this street used to be. This animation is a 3D model of Inariyama. In this animation, the historic houses are shown in brown, and the newly rebuilt houses are shown in light green. On the other hand, if all the houses were historical, the streetscapes would look like this. This is only a simple simulation, but it may give us an idea of what the streetscape might have looked like in the past. Using the above characteristics as clues, we generated 3D models automatically. Let us take Kawagoe as an example. The planar shapes of the buildings that form streetscapes can be obtained from map data. In this study, we use the basic geospatial information provided by the Geospatial Information Authority of Japan and partially used the OpenStreetMap. We extracted the street and the plans of the buildings facing the street from the map data. We added the center line of the street if the map data did not contain it. So far, the work is done manually by hand. Using the computational form generation method, 3D models can be automatically generated by giving the dimensions of the forms as parameters to the rectangular plane shape. We used Grasshopper, a visual programming package running on Rhinoceros, a 3D modeling software. First, to simplify the roof's forms, we made a program to convert the planar shape of the buildings into rectangle that encompass them. Second, the rectangle is classified into hirairi, gable, and modern. If we need to classify strictly, we must conduct a field survey to identify the types and classify them manually. However, for the simplified model, we can automate this process by using statistics for probabilistic classification. We organized the gable at 5%, modern at 30%, and the others are hirairi. Then, we coded a program that automatically generated 3D forms upon those rectangles. Hirairi often has another orthogonal ridge at the back. Our 3D model extracts a certain portion from the front street and excludes the form at the back. The height of eaves, the slope of roofs, the depth of houses, and so on have different dimensions depending on the use of the street and local characteristics. As each dimension has a certain degree of fluctuation, the models have parametric measurements based on uniform random numbers. For the two-story house in Kawagoe, the parametric dimensions shown in the figure were given, such as the height of the eaves on the second floor is 6 to 7.5 meters. These parameters were estimated by the field surveys and measured drawings in several locations. Since the parameters vary depending on the local characteristics, the streetscapes will not look like them if the appropriate parameters are not given. Then, the gable roofs were generated by giving the height of the building and the slope of the roof in fluctuated numbers. Finally, the modern roofs are extruded into box shape. In this study, we explored the streetscapes of existing historic preservation districts. Then, we presented automatically generated 3D models that express the characteristics of the streetscapes. We considered that these characteristics can explain the diversity of streetscapes. The images of the streetscapes are represented by adapting the roof type to appear probabilistically and giving an inevitable fluctuation to the building dimensions. The characteristics of the arrangement and the dimensions of historical houses will provide clues for expressing the images of historic streetscapes that have been lost or will be lost, and map data as a geometry has the potential to evoke images of historical streetscapes of the past. Thank you.